Hello, good morning students. My name is Suvas Vora, the Assistant Professor of Electrical Department at Sri Swaminarayan Institute of Technology. In the previous topic, we can see that the differentials protection systems, then after the disadvantage of the differential system, which one is unaccurately operated when the external fault will be arise, and the second one is the city will be saturated when the secondary current will be changed. It means that the external fault will be arise at that time, the secondary will be current is difference from flow through the external part. So remove this disadvantage, we can use the percentage differential protection systems. So you can see that we can put the restraining coil with the operating coil. So this one is called the whole arrangement called the percentage differential relay to remove our problems for the differentials protection system. So now today's topic is zone protection systems, then voltage balance relay and busbar protection systems. So now in the previous topic we can see that the differential protection system how to apply in the zone protection systems. You can see that the zone of the differential protection system, the consider that the fault located at here, I consider that this one is the external fault will be arise when the fault was outside the zone of protections. This is known as the external fault. Now the two cities have the same ratio. It means here this one is two cities and the ratio, it means that if I consider that 5000 by 5 amperes, so the both the cities have the same ratio and connected in the properly, and the secondary current are same magnitude and phase, so that the differential current being zero, so the no current will flow through the differentials relay and relay will not operated. When the fault develop in the protection zones, if I consider that here the external fault is arise, so this fault is the internal fault and the differential relay will operate when the fault developed because of the internal current of these cities and the output of these cities will be difference. It means that I1 is not equal to I2 and the circuit will be operated. So these all are about in the current protection systems for the zone protections and the differential type protections. Now if I consider that voltage balance differential relay, now consider that voltage balance differential relay, yes, you can see the basic diagram of the voltage balance differential relay. This one is almost similar for the current balance differential relay, only change that the cities are at the two ends will be connected in opposite directions. Here you can see that the opposite directions, so you can see that the basic difference of the current and the currents and the voltage balance differential relay, the relay are connected in series with the pilot wire. This one is called the pilot wire, and relative polarities of the cities is such that there is the no current flow the relay under the balance and through the fault conditions, so that the requirement of the city is that should be include the voltage in secondary linearly with respect to current. It means we know that the basic equations of the current and voltage V equal to IR, so that when the current will be increased at that time the current voltage will be decreases. So in order to that we can say that voltage should be linear functions of the such a large current and the city should be air cooled, so that the differential relay are ideally situated for the protections of compact items. For example, the electrical equipment such as the generator, busbar, transformer, and reactor, motors, and short transmission line, and etc. So, this one is the basic difference of the current and voltage balance differential relay. The both are working with the same principle, but consider in the current and voltage or the difference between current and voltage. So what is the applications of these systems is this system or the differential balance system is applying using the pilot wires or for the differential protection. So the protections of the transmission line can be done easily. So bus zone protection is applicable, then this system is also applicable in protections for large motor, protections of transmissions line, because by phase comparing carrying a current protections and the protections against the internal turn faults. So here we can see that one point, the protections of transmissions line by the phase comparing carrying a current protections. We know that in the three phase systems we can apply the basic systems to the difference of two phases. If any one phase will be failed, at that time the three phase motor will not be operated, so that this one is most important for the apply the perfect output of the differentials relay. So now the next one topic is circulating current protections for the bus bar systems. So circulating bus bar system, you can see the one basic example. The circuit protections is respond to the vector diagram or vector difference between the two and more similar electrical quantities. If I consider the merge price system, we can study the merge price system in the next chapters. So merge type protections can be used for protections of bus bar system. So you can see the basic circuits of the circulating systems. Here power is fed to the bus bar. This is called the bus bar through the generator, and there are the two outgoing feeder A. Here the five outgoing feeder A, B, C, and F. So now the scheme for the busbar protection involves, if I apply the Kirchhoff's current law, which states that the total current entering the electrical node is exactly equal to the total current leaving the node. You can see that here entering current and the outgoing current will be same. It means if I consider the whole current will be equal to 0, hence the total current entering into a bus sections is equal to the total current leaving from the bus sections is same. Now the principle of the differential busbar protection is very simple. If Here, if I consider that the secondaries of the cities are connected in parallel, so that means the S1, S2, S3, 5, S1 is the terminal for the connected together from the bus bar, and the similar way the S2 terminal of the all cities are connected together from the another bus wire. So tripping relay is connected across the buses. Now here you can see the figures, the A, B, C, D, E and F are carries the current IA, IB, IA, IB, IC, ID, IE and IF. So that if I applying the Kirchhoff current law, so this one is equal to 0. So entering the all cities used for the differential buffer protections are same current ratio. Now we can consider the secondary current must also be equal to 0. So we can say that they are connected in parallel with the city's secondary current IR, R2, IR, IA, IB, C, D, E and F, and applying the KCL at a node X. It means the applying the KCL so that you can see the equations of this. If I applying the the KCL, the equations will be 0. IR, IA, IB, IC, ID, IE and IF of the summation, this one is 0. IR is the basic resistance current, so that we can say that IN plus, here you can see that the IR plus summation of all secondaries current equal to 0. So we can say that if IR plus I0 plus 0 equal to 0, so that the sum of all secondaries current is 0. So it is clear that understand the normal condition there is the no current flow through the bus bar protections tripping relay. This relay is generally refers to the relay number 87. Now say the fault in occurs at any feeders the outside the protection zone. In that case the faulty current will pass through the city of the feeders, and this fault current is contributed by all other feeders to the bus bar, so the contributed part of the fault current flow through the corresponding cities of the respective feeders, so that the fault conditions the KCL at node, so the KCL at node K will be get the I R equal to 0. That means the external fault condition there is the no current flow through the relay here. Hence these conditions of the sum of all contributed fault current is equal to total fault current. Now the fault part is no cities. It means that we can consider here okay, we can see here the fault is connected on the bus bar and the fault is connected on the zone. So below figure is the external fault and upper figure is the occurrence fault. It means the in the transmission bus systems fault. So sum of the all secondaries current is no longer 0, is equal to the secondary current is equal to the faulty current. So applying the KCL at a node, we will get a no 0 value. It means that IR get some values and conditions that current start flowing through the relay. It make a trip the circuits so that the circuit breaker will be open corresponding to all the feeders connected to these sections of the bus bar. So here the all circuit breaker will be operated, and incoming and outgoing feeders the connected these sections of the bus bar will be tripped and the bus becomes dead. So this differential bus bar protection scheme is also referred from the current differential protection systems. Now we can discuss about the circulating currents and the protection for the bus bar. So these sections will be during the example of the working principle of the current differential protections of the bus bar. You can see the figure, the simple non-sections bus bar system. Now so this one is the basic circuit example of the situations of the non-sectional bus bar systems. In a moderate high voltage system, the electrical bus sectionized in then the one section to increase the stability of the system. It means that when the fault is one section of the bus should not disturb other sections. Here we can during the bus fault the total bus will be interrupted. Let us discuss about the protections of the bus bar with the two sections. Here we can bifurcate of the zone 1 and zone 2. It means that this one is the two different protection zone systems. Section A for the zone A is bounded with the city 1, here the city 1, city 2 and city 3 and city 3 are the feeder of the cities and city 3 is the bus cities. Similarly, the bus protection for sections B, the zone of B is bounded for city 4, city 5 and city 6, and the city 4 is connected with the bus protections of the feeders. So therefore zone E and zone D are overlapped to ensure that there is the no zone left behind this bus bar protection scheme. Now here the two terminals we can consider for the city 1, 2 and 3. You can see that 2 and 3 are connected together for the secondary bus bar, and similar way the cities of the 4, 5 and 6 are connected together from the secondary bus bar. Now the S2, here you can see that the S2 is the terminal of all cities are connected together from the common bus bar S2. Now the bus bar protections relay zone, here you can see that the two relays will be put for the zone 1 and this one is across for the S2 and another for the relay will be connected with the zone of the B. Now the bus bar differential protection scheme operate in the some manner simple current differential protection systems. This is any fault in zone A with the trip only circuit breakers CT1 or the circuit breaker of 1, 2 and CB 1, 2 and CB. This one when the fault will be occur in the zone A and the fault occur in a zone B, at that time the circuit breaker will be 5, 6 and again the CB will be operated. Hence the fault in any sections of the bus will be isolated. Only that portions for the live system. In the current differential protections of bus bar, the city secondary current or the bus wire is open, the relay may be operated to isolate the bus bar from the live systems, but this is not a disturbable. It means that here you can see that the basic difference in these systems. When the fault occurs in the internal bus bar system, at that time the all circuit breaker will be operated and the bus bar will be dead. So we can use only the two cities and we can given the two different zone A and zone B. When the any one of the zone will be faulted, so the this one is not affected for the other zones. So we can apply the circulating current protection for the bus bar system, because the only faulty zone will be removed, not to affect all the systems. So this one is the basic difference of the simple current protection system for the bus bar and the circulating current protections of the systems. So now today we will discuss about the, you can see that we can discuss the zone protection systems, then after the voltage balance differential systems, then after circulating protection systems, and we can see that how to bifurcate the zone A and zone B systems. If any questions regarding this, you can contact me, and if any query regarding this topic, you can also send me the message. My phone number and the contact number, the mail ID is seen your screens. Thank you.